This episode is brought to you by Brilliant. One day humanity might not just have homes that stretch up into the heavens, but farms and forests which rise into the sky too. So today we are going to be looking at Arcology Design, and we have to start by asking what Arcologies are. This is trickier than it sounds because Arcologies are a concept that's crept into public awareness with two parallel but distinct meanings. The first is the original meaning, where arcology is a portmanteau of architecture and ecology, coined by architect Paolo Soleri, who conceptualized it as essentially communities that were mostly self-sufficient and sustainable. But the definition popularized by science fiction writers has been more like a very large building that is a city unto itself, complete with farms and factories and living spaces. As is always the case with fiction, peaceful and prosperous civilizations tend to make for boring stories, and giant superbuildings that dwarf any skyscraper obviously have an appeal to sci-fi authors. So I think the view of them as mega skyscrapers is probably the better known one. Nonetheless, a more originalist view of them is probably to include any city or town that is at least moderately populous, mostly self-sufficient, but not techno-primitive. Portrayals can run from the not-quite-utopian, in which an impeccably engineered and maintained arcology houses a society that's just as regimented and controlled as their habitat, and turns out to have a sinister side, to the explicitly dystopian visions, often set in run-down and decayed arcologies left over from better times. Needless to say, a run-down megascraper where the only flora and fauna are humans, rats, and mold wouldn't seem like ecological architecture, but that is technically an ecosystem, and if everyone is eating recycled garbage and waste as NutriPaste, it is arguably agriculturally self-sufficient. We played with some of the more dystopian scenarios like Morlocks and cannibals in the sewers in our episode Mega Cities. So as we discuss design today, I'm going to try to look at both perspectives, the big superbuilding that contains a mostly self-sufficient city, and the more rural but technologically advanced options as well. To begin with, let's acknowledge that total self-sufficiency may be an option, and in some contexts a necessity, but is probably not a desirable goal in and of itself. For instance, a Mars base or O'Neill cylinder might be rather self-sufficient by choice, and an interstellar colony self-sufficient by necessity, being years from us in travel and communication. Nonetheless, total self-sufficiency is presumably only a goal as either a reserve of security or for those who are very isolationist. You might want to be able to produce all you need, but you will generally have at least some items you wish to import or export even if as luxuries, be it physical goods or video entertainment or tourists or what have you. We will try to discuss how self-sufficiency can be obtained across the board, but we will not assume an ideal arcology design means total independence from outside trade and interaction. A town running on solar power, even if they manufacture the panels locally, is still importing sunlight. So too it must still export entropy or heat, though we could imagine some super advanced technology indistinguishable from magic, what we call clock tech on the show, which circumvented both needs, like a city in a pocket universe with perpetual motion machines and something akin to a Star Trek replicator. We probably will never have those, but 3D printers are getting ever better and do offer paths to self-sufficiency for smaller communities. They could get good enough that an arcology might be applicable to very small communities, even families or individuals. Someone might have a rural log cabin in the woods atop an underground facility producing all their food and power and personal goods, or we could go even larger than the arcologies of big skyscrapers up to megastructures of planetary scale, not simply O'Neill cylinders but the bigger version, the McKendree cylinder continent-sized habitat. Fundamentally, a terraformed planet qualifies in arcology so long as it's both high-tech and ecologically sound. Nonetheless, we will keep our focus on the self-sufficient technological town and the city in a giant building versions. Let's start by looking at what they need. This is going to include things like schools, hospitals, police, fire and emergency personnel, and so on, but let's contemplate the main staples first. Obviously, producing the vast majority of your food on site is needed, as is stable water, air, and waste management. For a town on Earth, there is no special need for advanced technology to achieve this, but for a building it requires options like artificial lighting, vertical farming, massive networks of air ducts, and plumbing. It's a challenge too because if you are using natural sunlight, the areas most desirable for residential uses are on the outer edge of the structure, where agriculture is also most easily done. A recurring problem with a lot of fictional portrayals of food production tends to be way off about the scale of agriculture. While greenhouses, hydroponics, or some gardening focused on intense calorie per acre production can really let you squeeze food out of small spaces, though usually for large investments of other resources like time or money, the agricultural area of Earth is about 5 billion hectares or 12 billion acres. With about 8 billion people, that's about 0.6 hectares or 1.5 acres per person, and hundreds of times what the residential area per person is. Very intense use of climate-controlled hydroponics in artificially lit vertical layers can potentially allow you to grow all of one person's food needs in as little as 100 square meters, a hundredth of a hectare. And for that matter, food might not necessarily need to be grown, as in the case with Star Trek replicators or food printers using a base stock of something like algae, or even chemically synthesized amino acids, carbohydrates, and fats. Neither should we discount the reduced calorie needs a post-human or cybernetic civilization might have, or even that an arcology might be a big computer covered in solar panels in which a vast virtual civilization lives, like those we contemplated in Virtual Worlds some years back. Those folks might be entirely digital themselves or very adulterated humans living in sensory deprivation tanks with tubes bringing in nutrient or even just blood and air inside some giant building with vats growing artificial blood and a megaheart pumping it around, getting very literal with our tendency to discuss transport inside buildings or cities as analogous to veins and arteries. For the moment though, let's assume relatively modern crops and growing methods, being grown for contemporary humans to eat. If they wish to do this with sunlight, this still allows much compaction. Very approximately, food crops where photosynthetic conversion of sunlight to food calories is concerned runs about 1%, not terribly efficient, but a typical human needs the equivalent of roughly 10 million joules of food energy per day, or 1 billion joules of sunlight. Which probably sounds like a lot, indeed it is the equivalent of a bit over 30 liters of gasoline, or a bit under 10 gallons. However, while it varies by time of year, weather conditions, and how far north of the equator you live, the average sunlight falling on a given square meter of Earth is 21.6 million joules. So 46 square meters or 500 square feet per person would hit the needed sunlight input, assuming you were able to make sure virtually all of it was hitting leaves or algae or what have you, possibly by clever use of large fiber optics and mirrors and reflective foils on those surrounding surfaces that were not photosynthetic, like putting a reflective film on the wall of a growth chamber or on the dirt the plant was in. Such being the case, a building whose effective solar absorption footprint was a square kilometer could support 20,000 people, depending on latitude, assuming minimal losses or uses for other things like regular power generation. 10,000 would probably be on the upper end of plausible though. In this case by footprint we could either be talking about a big rooftop, a giant building can be short and just very wide, like a bunch of connected domes in a tundra or on Mars, or a tall structure whose sun-facing sides were principally windows to let light in, or some combination thereof. If they are very good with light, they might split the incoming sunlight into those wavelengths and ratios optimized for photosynthesis, mostly red and blue, while diverting most or all of the green and infrared parts of the spectrum into power production. And by the way, if you're surprised that plants don't use green light, remember that leaves and all green things are green precisely because they reflect green light, so we see the part of the spectrum that the plants do not use. And a lot of the spectrum that plants do not use for photosynthesis is also in wavelengths we cannot see either. We often contemplate artificial lighting from nuclear fission or fusion, or even energy beamed in from orbital power collectors, though the latter is much more of an external jugular vein than sunlight or deuterium or hydrogen for fusion, or materials for fission. Fission and fusion fuels could be mined in deep subterranean levels of the superscraper, or externally sourced but stockpiled abundantly, and they don't take up much room. However, we need to keep in mind that for every joule of heat you bring in, your arcology needs to radiate off a joule, or it will heat up until you fry yourselves. So just your superscraper needs a large bank of solar collectors expanding around it, it will also need a big bank of radiators too. In the absence of a big liquid supply on hand like an ocean, the radiators might be as space-consuming as your sunlight or power collectors. Indeed, you might use arrangements that utilize the space for both power collection and heat radiation, collecting sunlight or heat during the day and pumping waste heat away at night. The radiators might be more useful than you'd expect though. If the arcology is located in an area that gets cold in the winter, that waste heat might be piped around the surrounding streets and highways, keeping them free of snow and ice all winter, or it might be sold to heat smaller surrounding buildings, or you might heat vast swimming pools or even be used for farming greenhouses or alternatives to vertical farming or open-air agriculture. During the summer or in hotter climate, the waste heat might be used to convert seawater to fresh water. Alternatively, this tremendous excess of heat could be used to maintain agriculture and comfort in an area that is normally much too cold, such as Antarctica, the Atacama Desert, or the Kamchatka Peninsula. Due to the high density and self-sufficiency of an arcology, it would minimize the environmental impact on these locations, while moving people out of areas with higher natural biodiversity such as temperate and tropical zones. A natural location for at least some of the radiators would be to have them project from the structural beams between exterior windows. If you make the radiators transparent and use algae-filled water for your coolant fluid, you might also get them to grow agricultural feedstock, reducing your lighting bill without meaningfully impacting the amount of window space available to residents. Key notion though, when we're talking waste management for arcologies, it's a broader subject than normal. A large structure, potentially one so tall it may reach into another region of our atmosphere, needs to be handling waste of all types including exhaled air and excess heat. As an upside, the key concept of the arcology is that it is aiming for a mostly self-contained ecosystem, so things like exhaled carbon dioxide or human waste can be recycled by the plants you're growing for food. This though is problematic in off-Earth environments because when it comes to human food crops, the amount of carbon dioxide they need is not going to match what humans produce without careful coordination and balancing. So too, you can probably always use machines that scrub CO2 more efficiently than a plant, or have plants that optimize for some sort of task, producing calories, recycling air, water, waste, etc., but not the others, so that balancing is vital. Arcologies are going to rely on masterful understandings of both biology and human psychology as much as more physical technologies. While a giant skyscraper on Earth is what is often envisioned in fiction for future arcologies, it would seem more likely that Earth will be the last place the architectural style catches on. On the other hand, it might be the first place it catches on, given that it's the only place humans live right now. And also given that we have to get decent at this technology before we can make a serious go at off-world living. I would also guess almost every arcology is going to have a few inputs or outputs that are viewed as exceptions to self-sufficiency, either out of necessity or the opposite, hyperabundance. An arcology on the moon is very likely to think of oxygen as a waste product they can't get rid of fast enough, rather than its usual envisioned role in sci-fi of being the thing they rely on importing, with the oxygen supply train as the colony's big vulnerable jugular vein. To the contrary, they should be overproducing it, which might make for a good trade item, but also might be something they have to give away or even pay folks to take, or just dump on the moon's airless landscape. We discussed that in greater depth in our various episodes in the Moon playlist, but in summary form, the biggest apparent resource of the moon besides abundant raw sunlight is all the minerals that we can access or refine, and ship off for a tiny fraction of what it takes to source material for space from Earth. However, the biggest ingredient in almost every rock, mineral, and ore is oxygen, and it's often accompanied by water, which is 89% oxygen by weight. Smelting a ton of a given mineral will produce roughly the amount of oxygen a human needs for a year, and given that your food plants on site generally can scrub CO2 out of the air and restore it as oxygen, means you hardly need constant new inputs except for expansion. Indeed, generally the material used for building a structure is going to produce more oxygen when being made than the structure will need to contain, assuming you plan to recycle it. And oxygen has very little export value, as it is the third most abundant material in the universe and is plentiful wherever you find rock or ice, which tends to be where humans would set up shop anyway. One of the biggest critical concepts of arcologies, sustainable economies, and efficient energy in general is that one man's garbage might be another man's treasure, or at least something you can offload at a lower cost than burying it somewhere. It is strange to think of oxygen as not having a lot of value, this thing we can only live a few minutes without, but arcologies being built on airless worlds are likely to regard it as such. Interestingly, this might assist in slow terraforming since they might just vent it onto the landscape, especially the super hot byproduct gases of refining a metal. And the same is true of heat. You can generate power with heat, especially with large temperature differences like molten metal compared to room temperature, but doing so is often viewed as more expensive or complicated than it's worth, and technologies that alter how easy it is to do might impact arcology design a lot. Which is true of many technologies. In a fusion-powered economy, it would seem likely you would run all your lighting for agriculture on artificial light, and pack your agriculture in the central region of any given floor of the arcology, leaving the outer layer for residential usage as people like windows, or the lower levels, potentially growing all your food very deep down. You can use abundant power to fix almost any problem by sheer effort. As we say on the show, if brute force isn't working, you won't use enough of it. So you might build an arcology next to a river or ocean and use that for cooling, and just use fusion to power your way to self-sufficiency. Alternatively, efficiency is always desirable, so you might run your lowest levels as mineral extraction, delving ever deeper or outward as you create endless tunnels in lower levels. Above that would be your power production and smelting. Above that, either automated factories or hydroponics, which are resistant to heat or enjoy it. Then human-staffed non-automated factories above that, possibly all still underground. Then possibly a big tower rising up the sky, whose outer skin was residences. Mid-region was parks and commercial regions for each level or block of levels, and maybe in the central core a giant shaft to move heat up, serving as a huge thermal power tower. Or maybe a way for launching things directly to space like a big space gun, though probably only using a railgun, or mass driver type. Speaking of levels, one of the issues with super tall buildings is what we call the elevator conundrum, something we discussed before in our original Arcologies episode many years back, and our more recent episode, Mega Cities. This is the issue of elevators taking up the same amount of space on each level for elevator shafts. A building 5 stories tall with one elevator shaft might have a shaft footprint of roughly 5 square meters or 50 square feet per floor, for 25 square meters for the building over those 5 levels. But one 10 stories tall needs twice as much for that one shaft, 50 square meters, while at the same time it presumably has twice as many residents needing twice as many elevator trips, or twice as many elevator shafts, so now it's 100 square meters, not 25. However, the elevator trips take longer if everyone is going mostly from their residence to the ground floor, loosely speaking twice as long for going to the 8th floor than the 4th. You would need to double your elevator once again to account for the longer trips. Before long, you are using a lot of valuable floor space for elevators, and this is a real bottleneck on residential high-rise and skyscrapers, as they also tend to cost more to build and maintain per square foot of internal area than shorter structures. Given the option of building twice as high, you might find it costs not double but 4 times as much, and that elevator space is costing you half of your new space anyway. Though, living in the same building you work in will reduce elevator demand compared to modern skyscrapers, and careful design of other facilities and their proximities to each other can reduce travel times and distances. Stairs may even prove to be a desirable feature not just to reduce elevator congestion, but for opening up interior spaces and exercise too. Cities are valuable real estate, so it can sometimes be worth it to build pretty tall in them, but arcologies are seen as cities in and of themselves, so the location angle doesn't seem to apply as much. When built in the middle of nowhere, there's the question of why you bothered building tall. When building in a larger city, there's the question of why you devoted internal floor space to food production instead of moving it to the outskirts. And even if you were doing vertical farming, it would be hard to reason why you weren't doing it in high-rise on the edge of things, especially given how heat-intensive lighting is. You go much over 10 layers of plants, vertically, and your total irradiance per area is going to exceed natural sunlight even if you're being very optimized with your lighting usage and spectrums for photosynthesis, which means it's going to get hot. Presumably you can use your own hydroponic plumbing for cooling, but I'm not sure that's very economically plausible, as opposed to just building sideways above a certain height. Alternatively, having a secure supply for your vital resources is worth a lot. If you need to have some product, paying more to produce it locally does circumvent issues about exposed jugulars and the very real cost of shipping. It also lightens the load on elevator issues in arcology, as presumably large and mostly automated growth chambers require minimal elevator service. More importantly though, if we think of each level of the tower as its own semi-arcology or each slice of maybe 10 levels, then most elevator trips are not going to the ground floor anymore, they are to something located on the same floor or one closely adjoining. Incidentally, the elevator conundrum is not limited to the up and down. In the broader sense, it applies to side-to-side motion, like busy roads and pedways. And if your arcology is big enough, you probably need to be considering internal roads or mass transit. So while to some degree it's beneficial to make each level of an arcology, or each wedge or region, almost a mini arcology of its own in terms of self-sufficiency, I think that would principally benefit us in the sense of having short commute times for things people have to commute to a lot. Which incidentally might not be those factories or hydroponic facilities, which may be very automated, or even their schools or other jobs. As the COVID-19 crisis taught us, remote schooling and work are often viable. Not that everyone didn't think it might be an option in the future or before that. We've done episodes on the topic long before the pandemic, but it definitely put a highlight and urgency on the notion. Plagues tend to be a particular concern in dense areas too, and an arcology needs to have options for quarantine and for handling the cleaning of air that's recycling through to everyone and carrying airborne germs, or shared spots for standing and touching, like elevators and the buttons that summon them. This is one reason why the grimdark versions of Arcologies, dark, decrepit, mold-stained, garbage-littered slums, crammed with people and despair, wouldn't seem very realistic. Plagues would tend to spread through them quickly if left in that sort of state, which makes for good dystopian fiction, but not good management. Unless your leaders are being evil for evil's sake, just to twirl their mustaches, or are rampantly incompetent, they're going to make sure the Arcology's main traffic areas are getting cleaned regularly for a host of reasons, one of which is that having your habitat's demographics alter into a mix of terrified citizens, infected ones, corpses, and presumably plague zombies is not likely to be advantageous, unless you are a full-on mustache-twirling villain, in which case recruiting an army of plague zombies for fun and profit might be appealing. Arch-villainy aside, the classic mega-skyscraper Arcology image is something of a logistical nightmare, but I have a lot of friends who are village, city, and county executives, and even the ones running fairly sedate in small towns seem to live on a diet of coffee and aspirin in trying to manage their places, so an Arcology might not be much worse, though I'm betting it would be. On the other hand, the whole point of the things is for streamlined efficiency, so if you did it right, then it probably ought to run like a smooth machine unless the gear seize up. Speaking of that, on the physical side of Arcology design, we might shape them like gears. I mentioned tall cylinders rather than more standard rectangle shape for skyscrapers, and partially that's because Arcologies make me think of cylinder habitats, but also because they minimize surface area of the structure relative to the internal volume or square footage of living area. However, while that minimizes building material and heat loss out the sides, that may not be desirable. People like windows, and so a big cylinder shape whose outside was more gear-shaped with many protrusions might be better, allowing more desirable living space. We talked about doing something similar when discussing geoengineering large coastal embankments or dikes against potentially rising ocean levels, by using a long wavy seashore with more coastline for people to use for homes than a long straight beach would have. Same concept here, we can sacrifice advantages of minimized surface because that surface area is so desirable for homes. That can be advantageous too. For instance, in Arcology in most situations you will want to be purging heat more often than keeping it in, and a big sprocket shape is better for that than a cylinder or rectangle building. You also have the option of hollowing out the center to make a big shaft down the middle, probably cog-shaped too. They could be big and well lit and formed into parks and plazas, maybe as big tall shafts, though probably one divided into vertical segments even if you had fewer of them than total floors. This area might make desirable exteriors for residences too, and maybe better ones for all of that. A nice garden park in the middle is preferable to looking out on an airless barren world like Mars or the Moon perhaps, and Arcologies are often shown as occupying brutal post-apocalyptic worlds which probably don't make for nice viewing from a balcony either. Such central shafts let you add a large new layer of exterior bordering residences proportional to how wide it is. Of course, it need not be down the middle, and Arcologies not only do not need to have vertically symmetric exterior walls, like a pyramid rather than a cylinder, they need hardly be symmetric at all. There are a lot of reasons symmetry can be handy, so too it is often easier to make a building narrower as you go up, but no symmetry is required. So too, you could jetty each level out to be wider than the one below it, an inverted pyramid or cone look. This just depends on your material strength, but is much easier on low-gravity worlds. We do tend to think of material strength as the hard limit on building height, and it is vastly higher on airless worlds with low gravity and no tectonics, and it would be very easy to do with buildings growing wider as they got taller on places like the Moon. But you could do them on Earth too, and another thing Arcologies might often want is direct access to space, which they might do by being very tall, but could also do by having long, strong wires reaching up to space, like the classic geostationary space elevator, or orbital ring, the active support structure hanging stationary in a planet's atmosphere we often discuss building, see that episode for details, but that same technology would make it very viable to construct towers tens of kilometers high, or even hundreds, that directly connected to an orbital ring, or which ran between the rooftops of many super tall Arcologies. Indeed, you could circumvent some of the issues with orbital rings needing to be circles around a planet by making your Arcologies essentially two shafts ending at the top of an upside-down U, like the hypothetical Big Bend skyscraper, as that's quite ideal for an active support structure like a space tower, and then serves as a pylon for building a long horizontal runway for spaceships or mass drivers. Personally, I love the classic cyberpunk image of vast pyramid arcologies, or huge rising megascrapers, but when it comes to arcology design and shape, it's not only hard to say what's most efficient, but we have to keep in mind that sacrificing some structural efficiency for beauty is likely. A new arcology should always be considered a bit of a luxury property to move to, even if it's just newer and bigger than neighbors, and it is likely great effort will be made to make them pretty or visually distinct, unique, and special, maybe more like an upscale shopping mall with offices, restaurants, hospitals, recreational facilities, and residences all mixed in. There are many options, and your biggest control factor, whether we're talking a small town or a big structure, one on Earth in an existing city, or in some barren desert or tundra in Antarctica or Pluto, and a lot will depend on what characteristics you need to optimize. So the sky is the limit on arcology design options, except of course that since most probably won't even be on Earth or constrained to our atmosphere, the sky is clearly not the limit. So I mentioned the elevator conundrum in today's episode, and an example of one of those tricky and unexpected math dilemmas that shows up in architecture and engineering. It also has all sorts of variations that would apply in the future to things like how many spacecraft could enter or depart a planet's atmosphere in a given day before overheating the atmosphere, which is definitely a concern for planets covered in arcologies, what we call an ecumenopolis or planet-wide city like Coruscant from Star Wars or other galactic capitals in science fiction. These sorts of problems are interesting as both possible future concerns and as fun examples to help demonstrate concepts and make learning more fun and engaging, and that's something our friends over at Brilliant understand all too well. Fun problems, games, and interactive learning are the keys to learning, and not only does having fun make learning more enjoyable, it improves how well the material is absorbed. Learning should be fun, cultivating a love of knowledge. And Brilliant's courses, quizzes, and daily challenges emphasize that, like their course on scientific thinking and puzzle science. Brilliant has something for everybody, whether you want to start at the basics of math, science, and computer science, or dive into cutting-edge topics like cryptocurrency or quantum computing, and they do it all in a fun and interactive way. If you'd like to join me and a community of 8 million learners and educators today, click the link in the description down below, or visit brilliant.org/IsaacArthur. So that wraps us up for this Thursday. Then we'll close the month out with a look at how solar flares might impact the Fermi paradox, and then on Sunday, May 30th, we'll have our end of the month livestream Q&A at 4 PM Eastern Time, hopefully from our new studio. Then we'll head into June with a look at the concept of two alien races, both evolving civilizations on the same world, and they might share it in peace. Then we'll look at some future Manhattan projects, which might be handy for those who can't share their world in peace, and we'll follow that up with a look at death rays. If you want to know us when those and other episodes come out, make sure to subscribe to the channel, and if you'd like to help support future episodes, you can donate to us on Patreon or on our website, isaacarthur.net, which I'll link in the episode description below, along with all of our various social media forums, where you can get updates and chat with others about the concepts in the episodes and many other futuristic ideas. You can also follow us on iTunes, SoundCloud, or Spotify to get our audio-only versions of the show. Until next time, thanks for watching, and have a great week.